Hello, CS341 students. Welcome to this video, a highly selective introduction to C#. And when I say highly selective, I mean it. What I'm going to do is I'm going to talk you through some of the most important features of C#, and mainly encourage and direct you to the C# documentation from Microsoft because it's quite good, comprehensive. So let's get started here. The first thing is a few words of terminology here. So we are talking about .NET, and this is sort of this sprawling development platform from Microsoft, and with it you can build all sorts of different products for all sorts of different targets. So it consists of languages. You can actually program .NET in C#, F#, and VB.NET. We will be doing C# exclusively in this course. It consists of a runtime because once you've written your code, you got to run it somewhere. It is not native compiled, it's running on a runtime. It has some fundamental classes, and that's part of the base class library. So when you make a C# console-based app, you're just going to be using the base class. But there are other frameworks. We're going to be using .NET MAUI in this class. If this was a web dev class, we might be using ASP.NET. If you're going to be building software, you need an SDK. Those are the tools for building it. And we're going to be doing all of our work in Visual Studio Code in this class. And then we have a package manager. So that's sort of it as far as the terminology is concerned. The most important thing to take away at this point is that Java and C# have a lot in common. Java came first. C# was Microsoft's attempt at sort of imitating Java to a certain extent. It has gone well beyond that, but they do have very similar syntax and terminology. If in doubt, just start writing in Java and it'll probably sort of kind of work, or at least you'll be very close. So let's take a look at our first program. Our first program, of course, is Hello World. And here you see it right here. You start off with a namespace. A namespace is like a package in Java. So everything that is in this file starting beyond this point is part of the console app1 namespace. It has one class called program. We're not going to worry too much about access rights at this point. We have a method. Notice that the method starts with a capital letter. That is a convention in C# that we will follow to the letter, so to speak, all the time. So this is a main method, and this is how you would print Hello World. Nothing too exciting here. When you first create a C, I like how I did that. When you first create a C# program, you can either do it as shown here, or you can use what are called top-level statements, in which case your entire program just comes down to one line. I don't like this. I'm more of a fan of that. So let's see how we do this how we actually create a project in Visual Studio Code. To make this happen, let me move this over here and let me dig up a Visual Studio Code window here. All right, that'll work, I think. And then what I'm going to do is I'm going to simply choose .NET New Project. And it's going to discover all the project templates. We just want at this point the console app. And we got to store it somewhere. I don't really care where it goes at this point. And console app 3 we'll call it. We want SLN. We want to show all template options because we want do not use top level statements to be true. So we click here, set it to true. Then we create the project. And let's see, let's get this out of the way. Let's get this out of the way, and let's take a look at our project. So another point of terminology about C#. In a C# program, everything comes as part of a solution, and a solution can consist of one or more projects. Here we have one solution with one C# project in it. I could make another project if I felt so inclined. I'm content with this one. I open it up and there's program.cs. Let's make this a little bigger. All right, there we have a fully running C# program. And to actually run it, I can just press, well, let me bring up the terminal, and then F5. I want to run C#. I want to choose this as my project. And there's a long way to go to get to hello world, but there it is. The next couple of slides just talk a little bit more about namespaces. Again, if you've used packages, there's nothing surprising here. If I have a class called person, as I do here, as you can see, it is in the namespace cool. Its full name, therefore, is cool.person, and if I wanted to, I could write cool.person everywhere. It gets to be tedious after a bit, and so if I say using cool, as opposed to Java's keyword, which we will not mention here lest we become confused, if I say that I'm using cool, that means that I can then write person, and it looks within the cool namespace, discovers there's a class called pool, and then a class called person within the cool namespace, and then the compiler will not grouse at us. This is in another namespace called meanwhile somewhere else. This slide simply illustrates the fact that there are certain namespaces that are implicitly available. The reason I'm able to write console.writeLine as opposed to system.io.console.writeLine is because of the fact that these are all implicitly used. It's a good thing. You don't need to worry too much about it. What you might need to worry about is how to create your own namespace, and that's actually quite straightforward. Now, I'm going to show you one thing about Visual Studio Code when you're using the C# extension. When you are in the Explorer sidebar, you'll see a list of all your files as you would in any project whatsoever in any context. But there's also something called Solution Explorer, and that's specific to C#. So if you open that up, and if you select the project that we're dealing with, which is Console App 3, then when you click a new file here, instead of just a generic new file, it offers you some things. And in this case, I could create a new class, and I'm going to call this class person. And it's put it in the Console App 3 namespace. If I want to create another namespace, I will create a folder. I'm going to call this, let's see, cool. And then I'm going to drag person into the cool folder. Do you want to move it? I do. And this now is going to go into the namespace cool. Okay, so that's how you would put something into a distinct namespace. And then if I wanted to refer to it from the default namespace of Console App 3, I would say using cool, and I could say cool.person Percy equals new. A reminder, we don't have to repeat the name of the class here. This slide simply notes the .NET naming conventions, which you should try to follow as best as you can in all circumstances. Now, this next slide's pretty important. It is the principle that in C# everything is an object. If you also happen to be taking mobile app with me, you'll know that in Flutter everything's a widget. In C# everything's an object. And you can see the hierarchy here. At the top of the hierarchy is an object. It's in the system namespace, but it's just an object, just like in Java. So for instance, our person over here is really a person, and it really extends object. And by the way, you can see we don't write extends, we write a colon here when we're talking about subclasses. But one of the subclasses of object is something called a value type. And a value type is what we're used to thinking of as the primitives in Java. So system.int32, system.boolean, all of these are in fact objects. They have methods. You can do things with them that you couldn't do with primitives in Java. It would be a pain if we had to write out these .NET types all the time. Even if we took advantage of using, we'd still have to write double and int32 and so forth. In an attempt to make the code look even more Java-like, however, Microsoft has introduced these C# type keywords shown here on the left. So for instance, instead of, let me just hop over here to main, instead of having to write, say, system.int32 age is equal to 10, I could write int32 age 2 is equal to 10, or the shortest yet is just to say int age 3 is equal to 10. These are all basically equivalent. I also like to point out one specialized keyword. Actually, Java may have this now. It's var. So I could say var age 4 is equal to 10. And because of the fact that I'm assigning it an int, it now recognizes that age 4 is an int as well. I'm not going to worry about int32, although it is sort of handy that you've got int64. They actually make it explicit, and int16, the actual size of the type. That's quite handy. All right, now let's talk about everybody's favorite class, the string class. And strings in C# look pretty similar to strings in Java. There are a few differences of note. So for example, let's suppose that I had a string here. Notice, by the way, I'm using lowercase s because of the fact that we can, and in fact, this is what Microsoft recommends. So we're actually going to be writing string with a lowercase s here. I know you're shocked. If I declare a string here called name and I assign the value Sarah, and I had another name, name2 is equal to Fred. If I want to know if the content of these two are equal, I actually do use, this is deliberate, I use two equal signs because of the fact that this, and we'll talk about this a little bit later, this operator has been overloaded. So this is actually doing a content comparison. It's going to compare the S and the F and say, nope, these two are not equal. That's one thing that's different. Another thing that's different is if I want to know how many characters are in a string, I use length. And this is called a property, which we'll be getting to shortly, not a method, so no parentheses required here. Isn't that nice? Another really great C# feature is string interpolation. And this example here shows pretty much everything you need to know. Let's suppose that I've got a string. Oh, I wish I'd made that lowercase s. I only discovered recently that ought to be in lowercase s, and that is Microsoft's preference. Anyway, we've got a string called item, and we have an int called cost. I want to print these embedded in a string, and so first of all, I take the string and I put a $sign in front. That's very important. And then everything that I want to embed goes in curly brackets. Very simple. This could be a literal, which would be a little bit ridiculous. It could be a variable, and it also could be an expression. And what it will do is it will evaluate, if it's a variable, it's simply going to provide its value. If it's an expression, it's going to provide the expression, and that's what's going to end up being printed. So let's take a look at this and simply go ahead and run this. And when we do run this, we get da-da-da, da-da-da-da. We have to sing a bit. There we go. The flower pot costs 50, or in pennies 5,000. So you should always use this. Don't use this plus this plus this. Don't use that old-fashioned concatenation. You want to use string interpolation. It's modern, and it's the way that I'll expect you to be doing it in this class. Formatting. Formatting is nice. So if you need to, you can specify you give the expression, and after the expression, you provide an optional width and a format string. So for instance, if I wanted to print out a contractor in 8 columns, I would do it as shown here. If I wanted to print out cost as a currency, I would print it out here. So if I have, it's sort of maybe a little bit weird. I don't know. I'm sure that the Microsoft software engineers knew what they were doing. If I have to specify a width, there's a comma and then the width. If I just have to specify a format string, it's just the expression, colon, and the format string. So we see some examples here. So a lot of power here in the old string class. All right, I'm going to skip over the next couple of slides, just mention that they exist. There are other ways to format. There are other format types. You should check this out. Also, there's something called raw string literals. You should check this out. Arrays. Arrays are worth knowing about. Unlike Java, C# actually offers true multidimensional arrays. And the way you do this is, as you can see here, you use commas to indicate the dimensions. So for instance, if I wanted to make something that was 3 rows and 4 columns, I would declare it as not just int bracket bracket, a pair of brackets as you would in Java, but in fact just one pair of brackets with a comma. Let's hop over here and provide a brief demonstration of this. So if I wanted to make something two-dimensional, let's say I'm actually just going to end up writing what I wrote here. We'll actually make this, we'll call this grid is equal to a new int, and we'll make it by, let's say, 18 by 24. This now has 18 rows and 24 columns. If I want to figure out how big each one of the dimensions is, so again, this is 2 dimensions. If I ask for grid dot, and don't be surprised, I can do this because an int array is an object, so I can apply methods to it. I can use get length 0. This is going to return 18. If I had said get length 1, that would return 24. Ooh, I see an excellent opportunity to demonstrate string interpolation here, so let's do it. Remember, like that. Grid has, and we're going to say grid.length, get length, not just length, get length 0 rows, and we're going to fall off the end of the screen here, and grid.get length 1 columns, and it's mad because I need to close off that curly bracket. There instead of there. And it probably also wants a semicolon about there. Okay, so let's make this so you can actually see the whole thing. Right, okay, and if we go ahead and run this, ooh, this is so much fun. I love writing code. It sounded sarcastic. I do actually love writing code. Anyways, grid has 18 rows and 24 columns. All right, the last topic we're going to cover in this video is nullable reference types. And this is relatively new for C# as of C# 8, so about 2019. And with a nullable reference type, this is for types that you anticipate might be null. And to create a nullable reference type, you just take any reference and put a question mark after it. So a nullable string, a nullable person. When you do this, the compiler is going to watch over you. And if you try and use a variable of this type without checking for null first, it's going to generate a warning. The non-nullable reference types are ones that you never are going to allow to be null. And so you don't need the compiler to check for you. You're simply going to do it yourself, as it were. So let's take a look at an example here. If we go before 2019, here's what the situation was. You could assign null to a string. Compiler didn't care. You could write name.length with a value that you just told the compiler was null. The compiler won't care. When you enable nullable, then if you assign a value here, it warns you because you're using a non-nullable reference type and you are thinking this is not going to be null. Now, you can always assign null to a variable, but in this case, the compiler is going to warn you about it. And if you try and print it out, it is going to give you a warning here because, of course, you're dereferencing what is in fact a null reference. If instead you use a nullable string as the type, then you can assign it null, and the compiler's fine with that because you just said this is nullable. It could contain the value null. You're anticipating it. And if you write name3.length, it's like, hey, not so fast. The same error that you got up here. but with the nullable reference types, you can check first. And the compiler, if you put an if statement here, the compiler will see, this isn't null. Okay, this is going to be fine, and there's going to be no warning. So again, you could completely ignore this slide. And the only difference that you're going to encounter, apart from the fact that your code probably isn't as safe, is the fact that you're going to have problems show up here. Let's take a look at an example. I've actually got this up here with person. All right, and so right now I have got two fields. We're going to talk about terminology in a little bit. Two fields, name and age. They're basically instance variables, but field is Microsoft's terminology. And as you can see here, I'm doing the usual bit. I'm assigning a parameter to a field of the same name. And when I do that, it warns me about this second constructor, because this is non-nullable, and yet after this constructor is finished, this is going to contain the value null, which isn't good. Now, because these are value types, they always have a value associated with it. In this case, age is going to have the value 0, so it doesn't care about age. But I'm going to take string here, and so one way to solve this problem is just to do that. And now I have no problems, because what I'm saying here is name might be null, and if it happens to be null, then don't worry about it. It's just sort of normal. All right, I think that's all that I want to say about nullable reference types and classes. I think I'm going to talk about this a little bit in class, but that's it for this video. The next video, we're going to start talking about classes in detail. So thanks for watching this video, which was created with a product called Tella.